All right, our next speaker is Estela Franco. She's a web performance specialist for Schneider Electric. She's also a Google developer expert in web technologies and also a Storyblock ambassador. You can find out more about her on estelafranco.com. I'm really excited to introduce you to Estela because we share a passion for a particular issue, which you will learn more about in her presentation and why. And by the way, I work at Shopify. So when you look up there and you see our numbers. All right, everyone, please give Estela a round of applause.
Thank you. Thank you. Hello, good morning. I'm thrilled to be here today to talk about challenging assumptions about LCP best practices with data. So the first thing that you may think is, why are you still talking about LCP? Are you from the past? I mean, everybody knows everything about LCP, right? We know the thresholds, the best practices, the techniques to keep this metric under control. So to answer that question, I want to take a step back. Okay? In fact, I'm going to talk about the past, the present, and the future. So it seems like I'm going to talk about time travel. So I need, sorry, what's this? Oh, I can't believe that. Demo effect. Sorry. Really, what's happening here? What's happening here?
Try password 123.
Sorry. Okay, so it seems I'm going to talk about time travel. So I need a better background for my presentation. Yep, that is much better. So let's move to the past. So far, we've been focusing on our classic and beloved core web vitals, LCP, feed, and CLS. But a new metric has come to the core web vitals town. INP is here, traveling from March 2024 when it will become stable core web vital. Okay? And that's really bad news for feed because INP is here to shame and replace FID. And the web performance community is super excited about this new metric. Don't get me wrong, I'm also super excited. I mean, who wouldn't be with all that JavaScript and long tasks and style calculation? So yeah, it's amazing. It's really incredible, this metric, right? But now let's move on. Let's move to the present, and let's see how these metrics have evolved over time. And you can see LCP has evolved a lot over the last years. You can see here, since it was launched in Chrome 77, that was September 2019. And a lot of things has happened since then. You can see a lot of implementation optimizations, bug fixings, and definition improvements. And do you remember? Come on. Well, do you remember how CLS used to be? Now it's a much better metric that it was designed to be, right? And again, a lot of things has happened since it was launched over the last years. But what about feed? It doesn't matter when you look at this metric. It's been a bad metric for a long time, right? And if you can see here, it hasn't evolved that much. And you know what? Even IMP has evolved even before becoming a stable core web vital. And the current approach is much better than other approaches that were tested in the past. If you got that joke, please come to see me after the talk, because it's a joke for real Back to the Future fans. So this was fun, but I haven't answered yet the question, right? Why I'm still talking about LCP. Instead of answering that question with words, I want to answer that with data. So let's have a look at the CRACS report. This is data for the last 3 years. It's data from August during the last 3 years. And you can see the percentage of origins with good core web vitals, the classic core web vitals. And you can see slight improvements year over year, but still less than half of the origins have good core web vitals on mobile or desktop. And if we break this information down by metric, we can see that LCP is the worst one. Okay? Even if we compare LCP with IMP, LCP is still worse than IMP. So hold on, I'm not saying that you shouldn't care about IMP. You should care about IMP. But LCP is still bad. It's not under control. So you also need LCP to pass the core web vitals. So that's why I'm still talking about LCP. because everybody knows everything about LCP and how to improve that, but data says that LCP is still bad. Okay. So why is this happening? So again, let's look at the data. In this case, this is data from the HTTP archive. And you can see that images are the most common LCP content type. And images tend to be harder to optimize than text-based elements, right? So it makes sense that images are causing like these bad LCP results. But let's break down the LCP. In fact, the LCP is composed by 4 subparts: the time to first byte, the resource load delay, the resource load time, and the element render delay. So to better understand these subparts, let's look at this waterfall. You can see that blue line for the HTML document request, then a couple of purple lines for some style sheets. I'm really sorry because this never happened before in this conference while I was sitting there. Okay. Then the style sheets. Then we have a green line for an image, which happens to be the LCP element, and then some yellow lines for some JavaScript. And after the last JavaScript, we can see the LCP mark. So where's every subpart? The time to first byte is the easy one. It's the time that it takes to the browser to get the first byte of information since the page is requested. So it's the lighter part of the blue line. Then there's a piece of time until the LCP element is requested. That's the resource load delay. Then the time from when the element is requested until it's fully downloaded, it's the resource load time. And the time until the element is actually rendered in the screen is the element render delay. So let's take a look close at each subpart and what we know about how to optimize them. First of all, time to first byte. The first thing you need to ensure is that your host is able to handle the traffic you send to it, because if not, it will be complicated to have a good time to first byte. Another good practice is to optimize your backend, because if your systems are really slow to generate the HTML response, that will impact the final LCP value, because this time to first byte delay. Then you can use a CDN, especially if your users are far from your servers. But this can be expensive, and not all the projects have the budget to afford it. But you can cache the content whenever possible. Okay, so that can also help a little bit. Also, it's important to avoid page redirects, because when a user clicks a link, all the redirects that the browser needs to follow until it gets the final URL are calculated as part of the time to first byte. Also, you can use a service worker. You can leverage its cache to improve this metric. And last but not least, you can also use 1 or 3 early hints for render critical resources. Last year here, Sia gave a really interesting and really fun talk about this early hints technique, so that's really great if you can check it. Moving on, the next one, resource load delay. In this case, you need to focus on 2 aspects. First of all, you can optimize when the resource is discoverable. In short, your LCP, in this case, the LCP element, the LCP image should be discoverable by the preload scanner. So to do that, it's important to avoid JavaScript-generated LCP elements, because, JavaScript, the browser needs to download the HTML, then discovers the JavaScript, then downloads the JavaScript is executed, and we finally have the content, right? So that's too slow. And also, if you are loading the LCP image from style sheets, it's important to preload them, okay, to make sure that the preload scanner will identify them and download them. The other thing you need to focus on is to ensure that you gave the correct, proper priority to the resources. Okay? In this case, it's important to avoid lazy loading LCP resources. And here I want to make a little stop to go deeper on that. Because in fact, at Schneider Electric, where I work, we've been also facing several issues with that. In fact, we were lazy loading with JavaScript our LCP images in some pages, which is terrible, especially on mobile devices, on low-end devices. So this is something that you can easily fix. In our case, we went from something like this with all those data attributes that are managed by JavaScript to something like this. You have directly the resources linked from the element, the HTML tag, And that impacts a lot, especially on mobile devices, okay, because it's easier, the image is downloaded faster, and you can have massive improvement just with that. And in fact, I'm really concerned a bit about this topic. And last year I wrote, I was a blue girl last year. Now it's reddish. I wrote an article about this topic on the Perf Planet calendar because, it's an important topic for me. And in this case, the data that I used at that time, it was from Web Almanac 2022. And it says that almost 1 in 5 pages, mobile pages, are lazy loading their LCP images. Okay, so that sounds terrible. And if we split this data down by platform, you can see here that WordPress and Shopify were the ones with the worst issues, right? Moreover, Elementor, which is a popular WordPress page builder, seems to have also some important weight here, right? But during the last year, the WordPress team has worked a lot to improve this fix from the core, and also Elementor has improved this lazy loading feature to try to fix that from their end also. On the other hand, Shopify has also worked a lot on that. Yeah, that's Sia. I was really happy to see that Sia updated my data for my article to also keep monitoring this data while they were working on several improvements, right? And in fact, several conversations occurred around this topic, and currently the HTTP archive is storing the Shopify object, which also contains the Shopify theme. So now it's easier to identify if there are any particular Shopify themes that are maybe doing things worse than others, right? But you know what's even better than lab data? Field data, okay? And in fact, Shopify launched last week a table with internal data from the real users for their top 100 themes, okay? So for users, if you are using Shopify, you can go there and see if the theme that you are using is doing better or worse than other options in the market, right? That's great. Run data. So the point here, I want to keep encouraging you to continue looking at the data and sharing your findings, because as you've seen, the web performance community is amazing. You can have great conversations with platforms, with tools, with everybody, and you can help the website ecosystem to have better results. Okay, so I want to share this with you. Okay, so that's why avoid lazy loading LCP resources is bad. But you can also leverage the fetch priority attribute. And I know there's some kind of a skepticism about this technique, but even Google implemented that on Google Flights. And you can see here great improvements by just adding an HTML attribute to one tag. Okay, so that's an amazing quick win just by adding a tag. Okay, so moving on, the resource load time is the third one. What we know about how to optimize this subpart, it's, let's say, the most popular. Here is where we apply the traditional optimization techniques. It's important to reduce the size of the resource. This means that you need to serve the optimal size of the image. You can use modern image formats. You can compress images to try to reduce the size of the image resource in this case. You can also reduce the distance the resource has to travel from the server to the final client. In this case, the best way to do that is using a CDN. Also, it's important to reduce the network contention. So you need to make sure that you apply the proper priorities to all the resources to avoid many, many resources being downloaded at the same time. And you can also eliminate the network time entirely by serving the resources with the proper cache content policies. In this case, we're moving to the element render delay, the last LCP subpart. And if the delay is caused by style sheets, you can reduce or inline the render blocking style sheets when possible. We don't want, thousands of lines of CSS inlined in our HTML page. If the delay is caused by render blocking JavaScript, in this case, we can also defer or inline the render blocking JavaScript. Again, when possible, we don't want 10,000 lines of JavaScript there. Or sometimes the delay can be caused by unrelated long tasks blocking the main thread. In this case, we can identify them and try to break them up so the main thread is able to manage the render stuff to render the image in the screen. Also, we can use the server-side rendering approach instead of a client-side rendering approach, because with this approach, the image will be discoverable by the preload scanner because the HTML is there, the elements are there, so it will be easier. But this generally means that we will have more server work. Okay, so that may affect time to first byte. So as we always say, it depends, right? We need to test it, and we need to check if it's good or not applying this kind of techniques. But we can also apply the static site generator approach. In this case, we will pre-render the content in the server during a build time instead of on demand. So that will help to reduce the server work time. So, okay, we've seen the different subparts and what we know about how to optimize them, but what are the optimal subparts time? So according to web.dev, the LCP subparts should follow this distribution. Time to first byte should be about 40% of the LCP values, the resource load delay less than 10%, the resource load time about 40%, and the element render delay about 10%. And when you see this, you can think, okay, LCP threshold for the good packet is 2.5, then I can calculate that. Don't do that, please. You need to compare, it's a distribution. So don't take the values themselves calculated for one specific threshold. So you need to look at your data and the distribution for your LCP values, okay? But that's theory. But what's happening out there? And it's not a rhetorical question, okay? What's the biggest issue related to LCP subparts? And we have a Slido poll open, okay? Here you have it, the bigger QR and the URL, because I want to hear from you, okay? I will give you a few seconds, and you can vote for your bet, and we will check the results later. Okay, got it? Okay. So, to answer that question, which is the worst subpart, we need data. And where is the data? Yeah, I'm obsessed with data, as you can see. You have different options to get the data, okay? You can use PageSpeed Insights, which is already adding this breakdown for the LCP subparts. That's great because you don't need to develop anything. It's already built, and you can use it and get the data. But it's synth data, it's lab data. You are getting the results for a particular test run on Google's servers, in this case. You can also use Lighthouse. You will also get this information. Again, you don't need to develop anything. That's great. But in this case, you will get data from a particular test run on your computer. Then you can use the Web Vitals Chrome extension. You can enable that to get this information in the console login. You will have the LCP value, the LCP element, and then the 4 subparts and its values. Again, great. You don't need to build anything. It's already built. But again, you will execute that on your computer, and you will get the data from that particular execution. But you have more options. You can get this data in JavaScript using the LCP API, the navigation timing API, and the resource timing API. So at web.dev, you have this piece of code that you can use to get this data. And once you collect that data, you can do whatever you want. I mean, you can show this, you can display this information in the console logging, or you can add it in a beacon, or you can push it to the data layer, or you can push it to your analytics tool. So that's great. You have the control of the data, okay? And yes, it requires development, but it's worth it. I mean, you can get synth data, because if you are testing it, you can see it in the console log, for instance. But you can also get RAM data. And that's key to identify the actual real users' issues, to prioritize the implementations and fix the issues. But you can also use RAM tools. There are a lot of options in the market. All of them are currently monitoring one of these subparts, the time to first byte, right? But depending on the tool that you are using, maybe you get or not the other subparts. For example, if you are using Impulse from Akamai, currently they are collecting the time to first byte, but later this year, they will implement the resource load time directly from their servers. You don't need to configure anything on Impulse. So that's great. At least we will have more information, right, to go through that. And if you are using debug pair, they are also monitoring the time to first byte. But recently, last week, in fact, they implemented the rest of the metrics, so you can see the 4 submetrics in the specific experiences. So for instance, you can see here for a specific experience, you have the 4 subparts of that experience of a real user. So that's great. You can go through the worst results and see what's happening there. That will help you to identify potential bottlenecks and prioritize the fixes, right? Yes, time for a break to cancel this. Then, if you are using RAM Vision, they are already monitoring the 4 subparts. You can see it here in the metrics menu. You can navigate through the different subparts, and they also offer in their dashboards the distribution as a percentage distribution. Okay, so you can see here, for instance, the first screenshot. The time to first byte is 86% of the LCP, so it's easy to see where you need to focus to start improving that bad experience. In this case, it's for a product detail page group. And in the second screenshot, you can see the element render delay is like 51%. It should be below 10%. So yeah, it's really helpful to identify potential issues based on real users' data, right? So, okay, we've seen how to get our data, how to collect our data. That will help us a lot. But also, it's interesting to understand how's everyone doing. So in this case, we can use HTTP archive data. Okay? You can query it from BigQuery. And surprise, the LCP subparts are also available. So great, you can create your own custom query to get this data. But to be honest, it's not really straightforward. It's a query party. And here I want to send kudos for Philip and Rick because they helped me to get this data. And thanks to them, I can share this with you. This is data from the HTTP archive. So you have the different thresholds, the good, the needs improvement, and the poor ones, with the total LCP values and the distribution of the 4 subparts. And according to HTTP archive data, the most common scenario is the poor one. Okay? You can see here that the good and needs improvement scenarios, the distribution looks quite similar, but the poor one looks different. So we can go deeper and see it as a percentage distribution. And you can see here that even the distribution is not the same. The issues are quite common. In this case, you can see that the resource load delay seems to be the hardest, the biggest issue, okay? Because it should be below 10%, and it's like, 27, 28, 36% of the LCP values. And after that, the element render delay seems to be the second biggest issue. It should also be below 10%, and it's 18, 16, 23. So it seems like those subparts are the ones that we should start looking at to see if that's also a real bottleneck for our users. But this is lab data. I mean, the HTTP archive data comes from Lighthouse executions, and also remember that the HTTP archive is monitoring just a very few subset of pages for each origin. So it's like limited data, right? It can be really different from field data. And here is where we need to look at the future. So what's next? First of all, start collecting RAM data if you are not doing that yet. We've seen that you can do that with JavaScript, or also you can use several RAM tools, because with this data, based on that data, you can define your hypothesis, and that will help you to prioritize implementations, because based on what seems to be the real bottleneck, we will start addressing that to fix that big issue, right? After that, once it's implemented, it's important to validate in the lab, okay? Before the implementation, we have these values in the lab. Let's see if we are impacting those metrics, those values with what we implemented. And last, but the most important part, validate with field data, okay? Because if you don't see the impact in your real users' experiences, that implementation wasn't useful. I mean, we tried to make the web better for humans, not for tools, okay? But what if I don't have the budget or the resources to get the RAM data, right? Because we've seen that if we need to develop something to get the data and then collect the data, and then store the data somewhere to be, available to analyze and so on. Or if we don't have the budget to get the proper RAM tool to get this data. So how can we know what's the worst LCP subpart to help us in prioritizing the different fixes that we can implement? And here, I have really good news. In fact, I have breaking news, because coming soon to Crux, we will have the LCP subparts available in Crux. So that's great. Yes. Yes. That's the reaction I expect from the web performance community. This is really exciting because now, if you don't have the budget to get this data from your side, at least we will have the data available in Crux to identify those potential issues, as we are currently doing with the overall LCP values or with the overall CLS, feed, and IMP, right? So that will help us with the prioritizations and validations and so on. So that's great news, and I'm really happy to be able to share this with you here today. But I have more good news for you. I already traveled to the future and brought back data with me. And this is Chrome data from October this year. This is the LCP breakdown for the good, needs improvement, and poor buckets. Again, you have the LCP values and the different subparts. You can see the distribution is a little bit different from what we saw from the HTTP archive data. And as I said, HTTP archive is only monitoring a few subset of pages, also lab data and Crux monitors all the experiences, and lab data and seed data can be very different because of a lot of things. It's not your real users' experiences. And here you have the breakdown distribution. And they are quite similar, the three scenarios, right? The good, the needs improvement, and the poor ones. And we see something similar with what we saw with the HTTP archive data. In this case, the resource load delay also seems to be the hardest part. Remember, lazy loading LCP, I'm obsessed with that. Now you can see that I wasn't wrong. And then after that, the render delay is also like the second biggest issue, because those subparts should be below 10%, and in both scenarios are over that threshold, okay? So, did you get it right? Let's see at the data. Let's look at the data and Okay, you got it right. Good to see. You are really good on that. Again, other people didn't get the right answer in this case. But you can see that the element render delay was the last one. And in fact, it's like the second biggest issue. Okay, so don't forget about that subpart, because it seems to be the second worst issue. And again, when we are trying to optimize images, everybody comes up with okay, we need to serve the proper images with the proper size. We need to optimize images. We need to use a CDN. We need to use modern image formats. That's great, but it's really important to make sure that that's the best thing we can do now, okay? Because that's also something that I experienced in the past. Okay, we will optimize our images, and then nothing happens because we are suffering other issues, okay? In this case, maybe the resource load delay, so we have really bad values because of that subpart, okay? And in fact, that was really fast, because that was all that I had to share with you today. It was fast, yeah. I'm really good performance, right? I've been fast. So, thank you. I don't know if we have questions here to answer. Thank you. Thank you. Thank you.
Thanks, Estela. That was a really great presentation. You ready for your questions?
Yes.
All right. So in case you missed it earlier, when Estela did her article, it showed different platforms and how they performed on lazy loading their LCP, and Shopify was the worst. I think we were something like 67% of our sites were lazy loading the LCP. And I wanted to say that your data in that article really helped us get that recognition of the problem internally within Shopify, and it helped us to get approval for adding new features to that Liquid API. So do you want to kind of talk about the role of browser data sets like the Chrome User Experience Report and HTTP Archive to find and fix those problems?
Yes, in fact, that's the process that I did during the article that I wrote last year, because data is there, but you need to know where to look at, and then it can be a little bit intimidating querying the data because it's not as straightforward as a dashboard with everything already calculated. So it can be a little bit intimidating, but I think it's worth it because, as we've seen, in fact, and also you've seen internally, it can help a lot to identify potential issues. And in this case, as I said before, it's really good to have the data, to analyze that, and to talk to people. So that's the key point that I want to share, to encourage people to continue looking at the data and sharing their findings and have these conversations, because all of us can help to make the web ecosystem better, right?
Yeah. If you're actually more interested in those data sets, Rick Viscomi, I guess, does he leave both of them? Barry's also here. You can talk to Barry and Rick. They're from Google. But we can talk more. And also, there's a lot of great resources for helping you learn maybe what queries you need to write. There's a whole Slack organization for HTTP Archive. I also really hope that we can get more browsers on board with adding performance metrics. For example, big kudos to Firefox for about to release LCP. But I also wish that we had more. I feel like there's a big gap in mobile, especially for WebKit. But we have some more questions, if you're all right. Any good tips to optimize LCP for a video player or video content?
Oh, that's a really good question. It's kind of hard because, yes, it depends a lot on the video, where you are storing it, and also the different subparts, right? And how slow you get the video and it's downloaded and so on. So, wow, it's a hard part.
I know. So remind us, are the poster images now used for, so if you have a poster image on your video, that should be used for LCP, so maybe that would make it better?
The first frame. Yes.
So if you're missing your poster image, the first few frames hopefully will be used.
So maybe if you see some degradation for your video LCP values, probably it's because of that, because it's getting the first frame and it tends to be slow.
Yeah.
So that's
I prefer not having videos.
Yes, it's so challenging.
Personally.
Yes.
So this might be a question more for the Chrome team, sorry. But if most of the websites on the web have poor LCP values, aren't the current thresholds too optimistic and unrealistic?
Especially on mobile devices?
I don't know. Do you have any opinions?
I have an opinion, but it's more related to the element itself, because yes, LCP is monitoring the largest element, but sometimes that element is not content. For instance, the cookie notice, the cookie banner, that's not content. But many times it's the largest element, especially, for instance, in Europe, where regulations, you need to accept that you want to store the cookies to start monitoring the user. So that's why we have like those huge cookie banners. And on mobile devices, that's terrible because it's like almost the entire viewport. So yes, that tends to be the LCP element many times for new users. But in my opinion, that's my opinion.
I know.
It's not content from the website. So I don't know. For the user, the user doesn't count that as the most important part of the page, right?
And in defense of Chrome, I wanted to say that I do know that it was actually, part of it was based on research into human behavior. So it's not just arbitrary and hard to reach. It's actually that people will lose interest and are more likely to switch tasks. So that's part of why those numbers are that way. And even though we might not like that it's difficult to achieve, those numbers are still going to be true. We're still going to be distracted little primates.
Yeah.
I'm getting live notices to please extend the Q&A because lunch isn't ready yet.
Sorry.
It's like red font. So I hope you're okay with some more questions.
Yeah, sure.
All right. So looking through these new questions.
Oh, and if you let me, I want also to say something about the hardest part of all the process, because we've seen how to optimize the different subparts, but in my experience, the hardest part is to convince people, to convince the teams to implement those implementations. Sorry, and yeah, that's hard. And how many of you have suffered that that issue, trying to implement something and people, the teams have other priorities, right? So in my experience, it's really important to spread the word, to let them know, maybe even internal courses and talks, to let them know how important is not the code vitals themselves, but to make sure that the page is fast and that users get great user experiences, because that impacts not only, it's not because we want to have the better code, it's because it impacts businesses.
Exactly.
Right? So we've seen that it impacts on conversions and on revenue and on engagement. So it's really important to spread the word. And once you start, I think in my experience, it's important to maybe pick up a quick win, because maybe it's easier to implement. For instance, if you see that you can leverage some quick win techniques, as we saw, for instance, the fetch priority attribute or something like that. Once the team implement that and you can show the impact of that implementation, that's amazing how the teams get involved. Once they see that what they are doing is impacting business, is impacting the results. And many times, that's why I'm saying quick wins, because it's easy for them, because if not, it is a huge feature. Sometimes it's hardest to get it prioritized in the sprints and so on. But this kind of techniques is also helpful to get engaged with the developer teams. And also it's really important to know that if the dev teams many times use many anti-patterns as the LCP, as we saw before, but it's not because they want to, do bad things. It's because they think that's the good practice.
Yes.
And here I also want to say something, maybe it's not really friendly for the Chrome team, for the Lighthouse team, because Lighthouse also encourages to that kind of things, because, you can lazy load your images. But for many developers, that's not clear that they only need to lazy load what is outside the viewport, right? So they start lazy loading everything because Lighthouse says it's good. So it's complicated.
Yeah. I do think there's still one gap too right now. Currently, if you do lazy load your LCP, it only flags it on if you did it in a native way. But, and this was something... Is anyone still here from the Lighthouse team? We do need to add like the audit for if you if you lazy load via JavaScript library, which I think is still the primary way people are doing it. So if you have like lazy sizes, Lighthouse is currently not flagging that because it's more difficult. You actually have to detect for like data SRC or if a class of lazy load or something. But that's something that we can make sure they know so that they can actually like help spread the word of that anti-pattern. But that was a great note about like encouraging people within your organization, because you actually are you're not a performance consultant or on a performance team. You're just well, actually it's kind of similar to us. We're in an organization where they may or may not recognize the value of that work on performance, and how do we understand what is motivating different people so that we can get them to advocate for change as well.
Correct. That's the point. That's why I'm saying that spreading the word internally and talk to the dev teams, talk to the product owners also to let them know why is this important, even if it's not like the new bug fixing or feature for the new, I don't know, they want to implement something for the users flows or whatever. So, but it impacts businesses and money, and that's important.
For sure. I have a note that suggested sword fighting. I think we'll skip that one for now. Is there a way to avoid or exclude LCP on cookie banners in REM, or are we limited here in using lab data to get around this? I also don't know if you want to. I don't know.
I don't know, depending on the tool, I don't know how they are really storing.
Or for me, like the cookie banner is a problem still, so I don't want to forget that that's a problem.
There are some workarounds, in fact, because, the cookie banner is the LCP element many times because we have like a huge piece of text, right? But if you split the text into separate paragraphs, and all the paragraphs are smaller than maybe some content you have behind the cookie banner, maybe the H1 element, then the LCP element will be the H1 instead of the cookie banner, because you have split it into separate parts. But it's a workaround. I mean, that won't fix that the cookie banner is really slow to be displayed in the screen, right?
Yes, for sure. So we have another question from Stuart. Could you expand more on business change? Any experience in relating LCP to revenue directly?
Oh, that's a really good one. It can be quite complicated. In my experience, we are a B2B company, so our public website is like a public catalog of the products and the services, so it's not directly converting because we have we have the e-commerce part for B2C, and we also have like an internal application for clients to do their stuff. So it's not impacting the sales of the company, the web performance in the public website, but it will help your clients go through to be more engaged with your product and your catalog, and whatever they need, they know that it will be fast to get the information. So that can help to have happy clients. In fact, even if it's more complicated to measure that, right? But in fact, you can directly ask them, because you can pop-ups with surveys asking them about the experience and so on. So if you implement web performance improvements and then those surveys show that they are more happy than they used to be, that's something that you can correlate.
Yes, definitely. Yeah, I know it's a little bit easier at Shopify because we can actually like pull up conversion rate and bounce rate numbers. So usually it's a pretty easy sell. Although I will say it varies a lot by like type of merchant and what they're selling, for sure. All right. So how relevant, I'm not sure I fully understand the question.
Okay, let's see.
How relevant is LCP compared to other metrics for apps? Like long-lived behind a login screen. Maybe they mean like web applications. So like, is LCP still relevant maybe for more application-like experiences? Maybe that's the question. We'll just go with that.
I don't really know. Yes. When a user interacts with an application or a web, they are interacting with a digital product, right? It doesn't matter if it's a web application, a native application. So those core web vitals are here to help us measuring the user experience. So I think it's relevant also in any context, even if we can't measure as we are doing on websites, right?
They're still like they're still apologizing to me that lunch isn't ready yet, but we are early. We can chat about other stuff though. We don't have to keep grilling poor Estela here. I'm like, are you ready for your 50th question? I don't know. What else is going on?
Well, in fact,
what's your favorite Back to the Future movie? I actually think that was a real question in here.
The first one, of course.
The first one. And why is that?
Good to know. Well, because it's the first one, and it's the first time that you get involved with with all these things, and with the the characters and so on,
and the world,
the cast. So, and the DeLorean, of course.
Yes.
So that's great.
Have you seen a DeLorean in real life?
No, never.
I feel like
Sadly.
they pop up sometimes in the U.S. Do they ever pop up here in Europe? No.